Hi all, welcome to cloudtechsclub. So in this lecture, I'm going to discuss about the Kubernetes Services. So Kubernetes Services is a resource which helps in providing network infrastructure to the pods which are running within Kubernetes environments. So let's go to the kubernetes.io. This is the official documentation. Search for the services and see the official documentation from Kubernetes regarding the service and its types. So what is Kubernetes services? So Kubernetes services are the resources that map network traffic to the pods in your cluster. You need to create a service each time you expose a set of pods over the network, whether within your cluster or externally. So in order to understand, we can say any incoming and outgoing traffic flow from the pods, this particular service resource will be used in Kubernetes. Or in order to access applications running within these pods, we need a resource called Kubernetes Services. So let's understand with a small diagram how it works in Kubernetes. So we have a service running on top of the deployment. So deployment we talked about in the last lecture. And these are our pods. So we have services. Let's say this is my deployment. This is my replica set. This is my pod 1. And this is my pod 2. Let's connect them. So you can see here the service resource is running on top of the controller. So any outgoing or incoming traffic for these pods which are running in the downstream, all the traffic will hit the services first and then it will be routed to the pods. So there are various types of services which Kubernetes provide. One is ClusterIP, another one is NodePort, third one is LoadBalancer, and the last one is ExternalName. We will also discuss about a few other topics with this Kubernetes services. One is core DNS and the Ingress Controller. Okay, so let's proceed with understanding the types of services which are available within Kubernetes cluster to provide networking infrastructure. One is ClusterIP. Another one will be the NodePort. Next one will be the LoadBalancer. And the last one will be the external name. So let's understand what is ClusterIP. So ClusterIP is the default and most common service type which is available within Kubernetes. This service will be only reachable within the cluster. Kubernetes will assign a private or internal IP address to ClusterIP service. No request to service from outside the cluster which can be made. ClusterIP service only meant for internal communication, or say a private communication. Let's take an example to understand this. So I have one Kubernetes cluster here, which is running with a master node and couple of worker nodes. So worker node 1 is running with the front-end deployment, while worker node 2 is running with the back-end deployment. So a typical use case of inter-service communication within cluster is a communication between the front-end and back-end components of your application within the cluster. So what it means here is, if any pod wants to communicate from backend deployment to front-end deployment, it needs to communicate via ClusterIP. So pod 1 will hit the traffic over the ClusterIP service running with the backend deployment, which will be carried over to the service which is running with the ClusterIP for front-end deployment, and will be forwarded to one of the pods or the desired pod within the front-end deployment. That's how the communication happens within the ClusterIP. No user sitting on the internet or outside the cluster can access these pods with the help of a service, ClusterIP. If any user sitting outside the cluster and wants to access these applications which are running within these pods, there are two types of services which can be configured to achieve that. One is load balancer, another one is the NodePort. So in case of a NodePort, every node IP address will get associated with the port numbers within range 30,000 to 32,767 for external communication. So in this diagram, you can see here the NodePort. The IP address is associated with the port numbers. We have two worker nodes, so two IP addresses are associated with the port numbers. Take an important note here. If you are making a service a NodePort, in the background it will create the ClusterIP service as well, which will help in performing the internal communication between pods. So every time you create a service type as a NodePort, ClusterIP service will get created automatically within the cluster. If you will create the service as in ClusterIP, only the ClusterIP will be created for performing the communication within the cluster. That's why a NodePort is an extension to the ClusterIP service. Let's understand how the traffic flow happens with the help of a NodePort. So user sitting outside the cluster will hit the internet, and from internet it will be routed to node ports, which are assigned with the IP address and the port numbers. It will forward this request to the cluster IP or the service for that particular deployment within the cluster, and the request will be forwarded to the desired pod within the cluster. So that's how the communication happens for the node ports, a service type with the node ports. If we already have NodePort Service available for users to access the applications running on these pods from outside the cluster, then why we need service as load balancers here? So let's understand with the help of a present diagram. Here we have only two worker nodes, so it's easy to remember the node port IP and the node port numbers associated with it. While in productions, we might have hundreds of worker nodes where it's not reliable or feasible to use node port IP or node port numbers to hit the traffic from outside the cluster, or to map the services with the applications to provide users with every worker node details. It is not possible. That's where service as load balancers was introduced. When service type as load balancer will be created, worker nodes, node port IP and associated port numbers will be added to the load balancers. So during the creation of service type as load balancer, a node port and the cluster IP also gets created. So you can see here, when a load balancer service type is selected, node port will also be created and the cluster IP as well. That's why a load balancer is an extension to the NodePort service. Later, the IP address of the load balancer can be mapped with the DNS, which can be provided to users to access the applications or pods running within the cluster. So let's see how the traffic flow happens when service type load balancer is selected. Application users will hit the DNS name, which is mapped with the IP address of the load balancer. Load balancer will forward the request to one of the node ports. Let's say a node port running on worker node 1. This request will be forwarded to the service cluster IP of the front-end deployment, and from here it will be forwarded to the desired pod where the application is running within the cluster. This traffic flow can also happen during the round robin fashion, where a load balancer can forward this traffic to the node port which is running on worker node 2. This traffic will be forwarded to the service with the cluster IP of front-end deployment, then it can be forwarded to the desired pod which is running the application. So that's how the traffic flow happens when service type load balancer is selected. So in order to summarize, service cluster IP is used when we have to create an internal communication between the pods, between the deployments, between the applications, while service type NodePort and load balancers are used when we would like to access these applications running within the pods from outside the cluster. Next is external name. An external name service in Kubernetes allows you to map a service within your cluster to an external DNS name. Then why we use it? So it lets your application in the cluster access external services using a simple internal DNS name without knowing the actual external address. Let's see how it works. Instead of an IP address, the service points to a DNS name outside the cluster. When the application calls the service, Kubernetes automatically resolves the external name to its actual name. For example, suppose you have a database hosted outside your Kubernetes cluster with the DNS name db.example.com. You can create an external name service in your cluster. So if I'll explain you this in a layman terms, in the past we have used something called ClusterIP to communicate within front-end and back-end deployment. While in external name service will be used when we have a worker node running the front-end deployment services which would like to make a use of on-premises database or any cloud hosted database where the service type external name will be used and database URL will be provided as an external name. For example, any administrator wants to communicate its Kubernetes cluster, which is running with the front-end deployment service, with the database running on-premises or any other cloud vendor. In that case, external name service type can be used. Alright, so let's proceed with understanding the Ingress Controller. So in case service type selected as load balancer, for each deployment serving the front-end web services, we need a separate load balancers, which will increase the costing for the load balancers. Ingress controllers help reduce the costs by requiring only one external load balancer. So for every deployment, for every front-end based application deployment, we need a separate load balancer, right? As we have seen in our older scenario, we need a load balancer for this service, and in case we have this deployment for the front end for the separate project, we need another set of load balancer. So we will have a lot of load balancers for every project will be created, which will increase the cost for the load balancers. So Ingress Controller will help in reducing the cost by requiring only one external load balancer. So let's understand how it works. So we have two worker nodes here. Let me take a different pen. Yeah. So we have two worker nodes which is running here, which will be used to run the Ingress Controller service. Ingress Controller will be deployed as pods. It will have its own deployment and service. In terms of service, it will have ClusterIP and NodePort. So ClusterIP for the internal communication within cluster, and the NodePort for accessing it outside the cluster. And this NodePort will be connected to the load balancer, connected to the external common load balancer. Now, if we are using front-end, back-end or database pods within Kubernetes cluster environment, we do not need to keep the service as NodePort and load balancer. Only ClusterIP is enough to have network access within cluster and outside the cluster. So we will use going forward the service type as ClusterIP only. We are not going to configure service type as a load balancer or a NodePort for the worker nodes. So if you will see the traffic flow, any user who is sitting outside the cluster will hit the internet, from the internet to the DNS, and from DNS it will get routed to the load balancer, and from load balancer it will be routed to the NodePort. NodePort of what? NodePort of worker node, which is running the Ingress Controller cluster. And this NodePort will send the traffic to the ClusterIP of Ingress Controller deployment, and this traffic will be routed to the Ingress Controller pod where the rules are defined. Rules: if a service or a traffic needs to go to the front-end deployment, this Ingress Controller will send the traffic to the ClusterIP, the service of ClusterIP of the front-end deployment, and from there it can route the traffic to the desired pod. So this is how the traffic flow happens with the help of Ingress Controller. I hope this is clear. Next, let's discuss about the core DNS in Kubernetes. So there is a requirement of DNS within cluster as well. If I'll go ahead and show you here, this DNS we are using for the external purpose, where the external load balancer is getting mapped with the IP address. But this DNS requirement is different. So there is a requirement of DNS within the cluster, within the Kubernetes cluster. Okay, so let's discuss why we need this. In case this ClusterIP gets deleted and recreated with the same name within the same namespace, it will have a different IP address, and that different IP address need to be remapped with the backend deployment pods or the ClusterIP service to access the front-end deployment services. In order to have the remapping getting configured automatically, we need to use something called a DNS name for this cluster IP. This gets automatically configured with the naming convention. If you have configured a service name as app within the namespace default, then the DNS name will configured as app.default.svc.cluster.local. So the DNS name for this cluster IP will be app.default.svc.cluster.local. So in case the service gets deleted, we can recreate service with the same name within the same namespace. It will have the same mapping present on the backend application side, and we don't need to update the mapping again and again. So I hope these things are clear to you now. If you like this particular video, please hit like, comment and share so that your colleagues can learn more about this. Thank you.